All right. So 8.2. Use the properties of parallelograms. Our objective is to find side and angle measures in parallelograms. Definition. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. Now the parallelogram has many characteristics, but the definition is the opposite sides being parallel, okay, as marked here. Everybody have it? All right. A theorem. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So this is a characteristic. Parallelogram, opposite sides are going to be congruent. So not only we know they're parallel from the definition, we also know the opposite sides are going to be congruent. In this statement, we would say if PQRS is a parallelogram, then PQ is congruent to RS and QR is congruent to SP. Questions there? All right. If a quadrilateral is a parallelogram, then its opposite angles are congruent. In this picture, if PQRS is a parallelogram, P is congruent to R and Q is congruent to S. Questions? All right. ABCD is a parallelogram. Find the values of X and Y. Okay, Carly, I'll get you caught up real quick while they're working that problem. We're talking about parallelograms. Definition of a parallelogram. All the opposite sides are congruent. Okay, that's the definition. Opposite sides are not congruent, are parallel. That's the definition. And then you've got characteristics. Opposite sides are congruent, and opposite angles are congruent. All right. So then, now we're working this problem. How would I find, let's do Y first. What would Y be? Taylor, what would Y be? Yeah, it's opposite of C. C is 65, so Y equals 65 degrees. How would I find X? What would I need to do there? Kaylee? Right, we know the opposite sides are congruent. So we'd say x plus 4 equals 12. Solve for x. X equals 8. Questions? All right. Find FG and the measure of angle G. Okay, so we know this is a parallelogram, but the opposite sides are marked congruent. Marked parallel. What would FG be? Jacob? 8, because it's HE is 8. FG is opposite, so FG would be 8. What about angle G? Brandon? All right. What's G opposite?
60.
Yeah, so it's 60. 3, find the values of x and y. How would I solve for x? Gunner?
It would be 25.
How'd you get that?
Because 25 times 2 is 50.
Okay, yeah, so what he did was he knew that the opposite angles are congruent, so 2x equals 50, and then he divided by 2, x equals 25 degrees, okay? And then the y, how could I find that, Eric?
18 minus 3. Or y plus 3.
Yeah, y plus 3 equals 18, because their opposite sides are congruent, so y equals 15. All right, any questions there? Okay. What do you remember about consecutive interior angles? CIA, remember what the consecutive interior angles? They're not congruent, but what are they? Anybody remember? Abby?
They equal 180.
Good, yes. When you add them together, they equal 180. X plus y equals 180. So we can make a theorem from that about quadrilateral, a parallelogram. If we have a parallelogram, then the consecutive angles are going to be supplementary because all these pairs of lines are parallel, so the ones next to each other are going to be consecutive interior angles. X and y are consecutive interior angles. They add to 180. Y and x are consecutive interior angles with each other because of these parallel lines. They add to 180 and so forth. So all these angles next to each other are going to be supplementary. Add to 180. X plus y equals 180. Everybody got it? In a quadrilateral, if it's a parallelogram, its diagonals bisect each other. The diagonals are not congruent, but they do bisect each other. They cut each other in half. In this picture, in PQRS is a parallelogram. QM equals MS, and PM equals MR. Questions? Okay. Here's an application. Part of an extending arm of a desk lamp is a parallelogram. The angles of the parallelogram change as the lamp is raised and lowered. Find BCD when ADC equals 110. Okay, so this angle right here is 110. We have to find this angle. Make a question mark. Question mark. What's that angle? What would it be? How would I find that angle? All right, so first of all, we have to identify, is it opposite or is it consecutive? Which one is it? Aaron? This angle is opposite that angle? Yeah, they're consecutive. So what do we know its measure is going to be? What? No, when they add them together, they're 180. 180 is a straight line. That's not a straight line. Abby? Yeah, it's going to sum to 180. So if this is 110, what do I add to 110 to get 180? I add 70. So the answer would be 70. All right. Diagonals of parallelogram LMO intersect at point P. What are the coordinates of point P? All right. What do the diagonals do to each other in a parallelogram? Seth, what do the diagonals do to each other? Logan, what do they do?
Or they bisect each other?
They bisect each other. So what could we say about this point P in relation to this line LN? Either line. It doesn't matter. Let's say LN. What do we know about point P in line LN? What is it? What is that point? How could we describe that point? It's the what? Good. It's the midpoint because the diagonals bisect each other. P is a midpoint. So we have to find the coordinates of P. If we know the coordinates of L and N, I can do midpoint formula, right? To find P. We know how to do that. The average of the x values, average of the y values. So we're doing the midpoint. We'll do the midpoint. I get my thing to write. Midpoint of Ln is going to be, the x values are going to be 1, and the x value of n is 6. 1 plus 6 divided by 2. Those are my x values. Then I take the average of my y values. My y values are 4 and 0 divided by 2. So that's going to be 7 halves and 2. So the answer is A, 7 halves, 2. Everybody remember the midpoint formula? You add the two x coordinates and divide them by 2, and then you add the two y coordinates and divide them by 2. That's how you do the midpoint formula. Questions on that one? Okay. There's the work. Yeah, you could have used O and M if you wanted to. You could have done the midpoint for O and M and you got the same thing. Okay. Find the indicated measure in parallelogram JKLM. All right, so what's NM going to be, Faith? How'd you get, why is it 2? Yeah. This line is bisected by they bisect each other, so if this is 2, NM is 2. Good. KM. Devin, what would KM be? What would the length of KM be? This segment. We just figured out that NM is 2, right? Yeah. NM is 2, so what's KM going to be? 4, right. Okay. Then we've got JML. The measure of JML. Okay, it's tricky. We got some different information here. How are we going to find JML, Gage? Carly, how would I find JML?
Add 30 to 30.
That's some misinformation there. Because we don't know, these angles don't bisect each other. I mean, the line doesn't bisect it. That's not a characteristic of parallelogram. Yes? Right. M is a consecutive interior angle with J. J is 110. What do I add to 110 to get 180? I add 70. So the angle is 70. So they gave you some misinformation there. We didn't need 30. 30 has nothing to do with it. It's this 110. Because these two angles are next to each other, they're going to add to 180. So JML is 70. That's 180 minus 110. All right. So if JML is 70, what's KML? Go ahead, Kaylee. This angle right here. What's that angle? Kennedy.
40.
How'd you get that, Kennedy?
I just did 70 minus 30.
Right. The whole angle was 70. This is 30, so what's left is 40. So 70 minus 30 equals 40. Okay, very good. Any questions? Okay, now we're going to do 8.3. Show that a quadrilateral is a parallelogram. So we're going to use properties to identify parallelograms. So in the last section, we knew if we were given a parallelogram, we knew the opposite sides were congruent, and opposite angles were congruent, and the opposite sides were parallel. In this section, we'll prove that a quadrilateral with a certain angle and side properties is a parallelogram. So we're going to kind of do the converse of what we did last section. So this says, in a quadrilateral, if the opposite sides are congruent, we can say this is a parallelogram. Not a new idea, just the opposite. We don't know it's a parallelogram, but we know its opposite sides are congruent. So then we can say, oh, that's characteristics of a parallelogram. This shape has to be a parallelogram. Same thing with the angles. Opposite angles are congruent. Remember, opposite angles aren't next to each other. These aren't opposite. B and D are opposite, and A and C are opposite. If the opposite angles are congruent, then we know we have a parallelogram. Did everybody have it? Do I need to go back? Make sure everybody has it all. Okay, everybody have it now? Okay. 8-9. This is new. We didn't talk about this last section. But if one pair, in this case BC and AD, one pair of the sides in a quadrilateral are congruent and parallel, right? So the sides have two characteristics. They're congruent and parallel. Then we know it's a parallelogram. Opposite sides are congruent and parallelogram. You only need to know something about two sides. They're congruent and parallel. Then we have a parallelogram. 8-10. If the diagonals of the quadrilateral bisect each other, that was a characteristic we had last section. So if they bisect each other, then I can say, okay, this is a parallelogram. All right, questions? Everybody have it? Ready to go on? Okay. So, examples. In a quadrilateral, WXYZ. W is 42, X is 138, Y is 42. Find Z. Okay? So, I would draw myself a picture just to help me visualize it. So we have this picture. W, you go around in order, W, X, Y, and Z, and then we label. W is 42, and X is 138, right? Y is 42. We have to find the measure of Z. Several different ways we could approach this, but if we have a four-sided shape, right, four angles, what do we know that they're going to sum up to? Okay, if you think of them as consecutive interangle, you know that because these two are supplementary, we would know these lines are parallel. So that means that yes, these two would add to 180. Another way you could think of it's already up there. Okay, is if it's got four sides, the four angles we know they add up to 360, right? In a four-sided shape. So I would just take 360 minus the other 3. What's left is 138. That would be Z. All right, now, knowing that Z is 138, is this a parallelogram? Why or why not? Taylor, what do you think? Is it a parallelogram? Gage, what do you think?
Yeah.
Why? What's our reason?
Because the opposite angles are congruent.
Right. Opposite angles are congruent. Okay, so that's a reason why. Everybody got it? All right. Next example. For what value of x is quadrilateral CDEF a parallelogram? What would x need to be? How would I solve this? We've got one pair of diagonals congruent. I mean, not bisected. Right? Which characteristic are we applying here to show this is a parallelogram? Which one deals with the diagonals? Eric?
The bisector.
Yeah, the diagonals bisect each other. So we already got one pair congruent. For these two to be congruent, for them to bisect each other, we have to know that 5x minus 8 equals 3x. Solve for x, so we would subtract 5x, so we'd get negative 8 equals negative 2x. Divide by 2, negative 2x equals 4. Any questions there? All right, so here's an example. We have an amusement park ride with the moving platform attached to 4 swinging arms. The platform swings back and forth higher and higher until it goes all the way to the top, all the way over the round. So AD and BC represent 2 of the swinging arms. We can see they're both 16, and DC is parallel to the ground with line L. Explain why the moving platform is always parallel to the ground. Has anybody ever ridden one of these? All right, it's pretty fun. They usually have it at the Johnson County Fair, so I think you might want to try it. Okay, so how do we know that AB is always parallel to the ground? What's our thinking? What do we know about this shape? Faith? It's not a rectangle because it's moving, it's changing all the time. But we know one thing about what do we know about it? Yeah. It's a parallelogram, right? Because the opposite sides are congruent. So no matter what the angles are, the opposite sides are going to stay congruent. So it's a parallelogram. So we know AB is parallel to DC, right? And DC was parallel to the ground. So if DC is parallel to the ground, AB would be parallel to the ground. Okay, here's an example. The doorway shown as part of a building in England. Over time, the building is leaned sideways. Explain how you know that SV is congruent to UT. There's 2 steps. You have to come to a conclusion first, and then from that conclusion, you would know those 2 sides are congruent. What do we know about the doorway as marked? Abby.
That one of the sides are congruent and parallel.
Right. The opposite sides are congruent and parallel. So from that we know what?
That's a parallelogram.
It's a parallelogram, right? So if it's a parallelogram, what do we know about SV and UT? They're congruent, right? It's logic, right? First you determine it's a parallelogram because of the characteristics, the parallel and congruent. Then if it's a parallelogram, then I can say something about these sides. They are congruent. So that's how that problem works. All right, summary. Ways to prove if quadrilateral is a parallelogram. Both pairs of opposite sides are congruent, are parallel. Both pairs of opposite sides congruent. Both pairs of opposite angles congruent. One pair of opposite sides are congruent and parallel, right? And the diagonals bisect each other. Okay, everybody have it? Who's still writing? Everybody's got them all. Okay. So, a few more examples here. What theorem can you use to show that the quadrilateral is a parallelogram? Don't do it by the theorem number. I don't want you to memorize them by the theorem number. I want you to know what the theorem is, the idea. So what idea tells us, how would we know 5 is a parallelogram? Look at the ones you just wrote down. Which one applies here? Eric.
Show both pairs of opposite sides. Oh wait, the one side of opposite sides are congruent.
That's not enough. Just one side, one pair of opposite sides being congruent is not enough. Kennedy?
Congruent and parallel.
Right. One pair of opposite sides is congruent and parallel. That's how 5 would be. Six. Devin, how do we know 6 is a parallelogram? Gunnar, how would I know 6 is a parallelogram?
Both pairs of opposite sides are parallel and
They're not parallel. Look at how it's marked.
they're congruent.
Yeah, they're congruent. Both pairs of opposite sides are congruent. 7. Seth, how do I know 7 is a parallelogram?
Both opposite angles.
Yeah, both pairs of opposite angles are congruent for 7. All right, any questions there? Everybody have all those? Okay. For what value of x is a quadrilateral MNPQ a parallelogram? What would I have to do to figure out x? What do I know? How can I solve that? Aaron, what would I do? Right. The diagonals, for this to be a parallelogram, diagonals have to bisect each other. These bisect each other. We have to show that these two bisect each other. So it would be, yes, it would be 2x equals 10 minus 3x. Solve for x, so 5x equals 10. X equals 2. All right, any questions there? Okay. That's it. Okay, now